Surface plasmon resonance. So, what is surface plasmon resonance? Surface plasmon resonance is a phenomenon that occurs when polarized light hits a metal film at the interface of media with different refractive indices, in which plasmons are collective oscillation of free electron gas. The term surface plasmon means these plasmons confined to the surface and they interact with light resulting in polarides. SPR techniques excite and detect collective oscillations of free electrons. It can be explained using Plasmon configuration, in which light is focused onto a metal film through a glass prism and the subsequent reflection is detected. One of the basic principles behind this technology is the principle of refraction of light. That is, when a light ray travels from a rarer medium to a denser medium, the speed of light reduces and it bends towards the normal. In optics, the refractive index or index of refraction n of an optical medium is a dimensionless number that describes how light or any other radiation propagates through a medium. Now we can take a look at the working of SPR. When a light is incident upon a metal film through a prism, and this reflected beam is collected and analyzed. At a certain angle, the plasmons are said to resonate with light, resulting in absorption of light at that angle. This creates a dark line in the reflected beam. The dark line contains a wealth of information. The resonance angle can be obtained by observing a dip in SPR reflection intensity. A shift in the reflectivity curve represents a molecular binding event taking place on and near the metal film. By monitoring this shift versus time, we can study molecular binding events and binding kinetics. Now we can answer some basic questions we might encounter. That what kind of interactions that we can study with SPR? We can use this system to study interactions involving any kind of molecule from organic compounds to proteins, nucleic acids, glycoproteins, and even viruses. Another question is that how is the surface plasmon resonance data displayed? The system monitors the interaction between two molecules, of which one is attached to the sensor surface and the other is free in solution. A sensorgram is a plot of response against time showing the progress of this interaction. This curve is displayed for us directly on the computer screen during an analysis. This is a picture of a sensorgram. The angle at which the dip is observed versus time is observed. First, no change occurs at the sensor and a baseline is measured with the dip at SPR angle. After the injection of the sample, biomolecules will adsorb on the surface, resulting in a change in refractive index and a shift of the SPR angle. This adsorption-desorption process can be followed in real time and the amount of adsorbed species can be determined. Coming to the advantages of this technique, firstly we can say that this is a less expensive technique and it's also easier to perform. Another point to note is that it requires only small sample volumes. It is also high sensitive that it can be used for small molecules to large proteins. It gave deeper insight into the binding kinetics compared to affinity techniques. These high sensitivity, real time, and quantitative measurements are some of the advantages of this technique. Applications of SPR. SPR is used to monitor binding events between molecules ranging from ions to viruses. The technology provides binding, kinetics, affinity, specificity, and concentration without any need of labels. The physical applications include measurement of dielectric properties, adsorption process, surface degradation, and hydration of thin organic monolayers, bilayers, and polymer films. The biological applications include the use of biosensors. It can be used as biosensors for specific biological interactions, including adsorption and desorption, kinetics, antigen antibody binding. It can also be used for the determination of biomolecular structure and interactions of proteins, DNA, and viruses, lipid bilayers, non-specific biomolecular interactions, biocompatibility, and tissue engineering. This technique gives a real-time binding data of both the association and dissociation phases of the interaction. Thank you.